Now we found our VC naught, our time of at our tau. We only need to find one thing left, which is Grant.
When t is equal to infinity.
That's it. T equals infinity to find our VC of infinity. So that's our third step. Time, redraw for time equals infinity. And our goal here is to find VC of infinity. So where is the, so Ben Wallace, what is the difference between drawing it at time equals infinity and drawing it for time greater than 0?
The switch.
Well, no. So in both cases, time greater than 0 and time equals infinity, Ben, is the switch going to be up or down?
It's going to be up.
That's right. So either way, it's going to be up. So what's the difference between time equals infinity and time greater than 0?
There is no difference.
Kind of not. So for time greater than 0, there really is that capacitor in there. We're just not drawing it because we want to find the resistance that it sees. But for time equals infinity, the capacitor really does just not exist there. It's the same as if it was not there. It becomes an open. And now, instead of finding REQ, our goal is to find VC of infinity. And can you tell me just by inspection? Cole.
9 volts.
9 volts. And why? Why doesn't the 100K matter?
There's no current going through it, right?
That's it, because there's no current. So when you look at this, you can see this current is equal to 0. And since there's no current, that means that the voltage across this resistor is, Cole?
0.
0
Ohm's
volts.
law.
So the thinking is that A, no current, B, no voltage across here, C, by KVL, the voltage between this point and this point is the same as the voltage between that point and that point, which is the same as VC naught. Anyone have any questions on that one?
So when you say it's similar to like what you're talking about with the battery, in that case too, like because of that, I mean, there's no current, but there's still voltage basically.
There's no current, but there's still voltage. Exactly correct. Exactly correct. At least across the capacitor. There's no voltage and there's no current across the.
If you just look at the third step independently, what was the point of finding tau in the second step?
Every one of these steps is totally independent. The goal of the first step is only to find VC naught. The goal of the second step is only to find tau, and the goal of the third step is only to find VC naught. And Josh, if you don't like the order, you could change that order around to do it exactly opposite or switch it around as any way you like to. You could find step 2 and then 3 and then 1. Makes no difference. They're all completely independent of each other. Does that answer your question?
It does, yes, sir.
Okay. Because remember that the overall goal of what we're trying to do is we're trying to use this thing on our left. And in order to do that, in order to plug it in, we need 3 things. We need VC of infinity, we need VC naught, and we need that tau. And that's what we did in our first 3 steps. And the only reason why I ordered them as I did is just because it sort of follows time. One is time less than 0, one is time greater than 0, one is time at infinity.